Have you ever wondered what a black hole really is? Forget what you've seen in movies. A black hole isn't a cosmic vacuum cleaner. It's a place where gravity has become so strong that it distorts space and time itself. The idea goes all the way back to 1916, when Karl Schwarzschild found a solution to Einstein's brand new theory of general relativity. He mathematically described a region of spacetime so warped that nothing, not even light, could escape. Imagine space as a river. Far from the black hole, the river flows slowly. But as you get closer, the current gets stronger. At a certain point, called the event horizon, the river of space is flowing inwards faster than the speed of light. That's why once you cross that line, there's no turning back. You're swept along, no matter how fast you try to swim against the current. And where are you headed? To the singularity. But here's the mind-bending part. The singularity isn't a place in space. It's a moment in time. It's an unavoidable future for anything that crosses the event horizon. For a long time, physicists wondered if these strange objects were just mathematical curiosities or if they could actually exist in our universe. Then, two physicists, Oppenheimer and Snyder, figured it out. They showed that when a truly massive star runs out of fuel at the end of its life, its own gravity becomes so overwhelming that it collapses in on itself without stopping. This unstoppable collapse is what gives birth to a black hole. Later, in the 1960s, the brilliant Roger Penrose provided even more solid proof that black holes are a natural consequence of the laws of physics. They aren't just possible, they're inevitable. Now, let's talk about the big ones, supermassive black holes. These are the true monsters of the cosmos, weighing millions or even billions of times more than our sun. We found one at the heart of almost every large galaxy we've looked at, including our own Milky Way. Ours is called Sagittarius, a star. How did they get so big? That's one of the biggest mysteries in astronomy today. One leading idea is that they formed from the direct collapse of enormous clouds of gas and dust very early in the universe's history, just after the Big Bang. So, what would happen if you fell into one? Let's get the scary part out of the way. If you fell into a smaller, star-sized black hole, the experience would be unpleasant. The gravitational pull on your feet would be so much stronger than on your head that you'd be stretched out like spaghetti. Scientists actually call this spaghettification, but falling into a supermassive black hole would be a completely different story. Because they're so huge, the gravitational forces are spread out over a much larger area. You could actually cross the event horizon of a supermassive black hole without even noticing. No drama, no immediate spaghettification. You could float right past the point of no return, but your fate would be sealed. You would be on a one-way trip towards the singularity. Over the course of about a day, as you got closer and closer to the center, the tidal forces would build up. Eventually, you would be spaghettified, your body stretched and torn apart until you were just a stream of atoms. This brings up a fascinating question. How big can a black hole get? Is there a limit? Theoretically, a black hole could grow indefinitely as long as it has stuff to feed on stars, gas, dust, even other black holes. The largest black holes we've discovered are tens of billions of times the mass of our sun. Their ultimate size might be determined by the very conditions of the early universe, how much matter was available in one place right after the Big Bang. The fluctuations in those primordial ingredients could have set the upper limit on the cosmic giants we see today. Now for a truly mind-bending idea. Could our entire universe be inside a black hole? It sounds like science fiction, but it's a concept that physicists have seriously considered. The idea is connected to something called the holographic principle. This principle suggests that all the information contained within a volume of space, like our universe, can be described by the physics on its boundary. Black holes are central to this idea because their event horizons act as these information-storing boundaries. So, are we living in a cosmic abyss? The evidence suggests probably not. Our universe is expanding, and as far as we know, it will continue to expand forever. But inside a black hole, everything is destined to end at the singularity, a finite point in time. Our universe's seemingly infinite future doesn't match the finite lifespan of anything inside a black hole. So while it's a fascinating thought experiment that helps us probe the limits of physics, it's unlikely that we're all just part of a larger cosmic object. From mathematical curiosities to the anchors of galaxies, black holes represent the most extreme physics in the universe. They challenge our understanding of space, time, and the very nature of reality. And the more we study them, the more we realize how much we still have to learn. Thanks for joining me on this journey into the abyss. If you enjoyed this, be sure to like, subscribe, and hit that notification bell for more deep dives into the cosmos. See you next time.